Hello, this is NetMaven. Today we're going to talk about the bandwidth management. This lab will show you how to deploy bandwidth management for preferred architecture in Cisco Unified Communication. It covers all aspects discussed in the bandwidth management chapter of preferred architecture of enterprise collaboration Cisco CVD, including the identification, classification, WAN queuing, and scheduling, provisioning, and call administration control. The only area of a configuration that doesn't include it is the identification and classification of on the switch. Instead, only identification and classification of the WAN ingress is covered in this lab. Let's log into my call manager. We'll have to take a look. Endpoint CQS is configured in the CUCM admin page. In the version 11, this down in SIP profile. The SIP profile specifically for all Java clients to use separates the media and the signal port range. That's value from 3000 to 3999 for audio, and 5000 to 5999 for video. So the SIP signal ports of 5060 is used for SIP signal, and 5061 for secure SIP signal. So the SIP signal port is configured in the SIP security profile in the CUCM. We'll take a look at the port number in here. So all the port number we have configured for the SIP signaling is configured in the SIP trunk security profile. Now let's take a look for the SIP profile first. The QoS parameter setting for the SIP profile of the Java endpoints we can see is in the QoS service parameters. We are identifying for audio, video, audio portion of video call, and telepresence call. They all are setting up here. For the media port range, we can navigate to the media port range, and we use separate port ranges for audio and video. Then here's the other ports we're talking about. For Java on mobile service, we recommend copying the standard SIP profile for mobile device when building a new SIP profile for these devices. So because the default standard SIP profile for mobile services devices includes the recommended timer values for maintaining Java registration on Android and Apple iOS devices. So these timers are required for any SIP profile assigned to a dual mode and tablet Java client devices. We'll go back to the tab of CUCM. I will log in to see the SIP profile specifically for all IP phones, smart desk, and telepresence endpoints to use a common media and signal port range value of 17,000 and 17,999 for audio and video. So this is SIP signaling port 5060 is used for SIP signaling, and 5061 is for secure SIP signaling. So SIP signaling port is configured in the SIP secure profile in Cisco CUCM. For example, we are going to navigate to the system and security. We'll find the SIP trunk security profile, and we'll find IAM and presence, or we could take a look secure SIP of CMS, and here's where we define incoming port. If I take a look at the SIP profile, find the other one is called SIP Java profile. And here, same thing, I define the port range, use the common port. I don't have a QoS, and other things are configured. If I go to my desktop telepresence QoS, the start media port I defined, and stop media port I defined, and this is the DPSPP value of default all defined well. Again, configure QoS on media originating and terminating application, and the UC MCU across the solution. This lab will cover some non-default configuration on all application servers in the PA. So it is also equally important to ensure that the switch ports to which application servers are connected to trust the QoS by set up by the server. So some switches, such as the Cisco Catalyst 3850 series, trust the QoS by default. So verify the switch configuration to ensure the switch port is trusted by default or enable QoS trust. So default QoS value must be changed in the Cisco CUCM service parameter to call manager service. Let's find this service parameters. We talk about is in the call manager service, and should be configured under QoS service parameter. Right here. So default DSCP for audio call is marked as 46 EF, and etc. All of this have been marked correctly in this, no change, right? So in CUCM, we'll navigate to these service parameters. We're gonna to pick up my call manager server. For example, we'll use this call manager active 1, active for my active call manager 1 and then call manager 2, and I have my persons also. For this lab, we change the default QoS value in Unity connection telephone page. Will show. Log into my Unity connection. We wanted to navigate to the system setting in the advanced telephony. Click here. We'll see the settings for DSCP value for the RTP video connection is set to 34. For the next thing we'll talk about is the WAN edge identification and classification. At the WAN edge on ingress from enterprise to the service provider, it is expected that the packets that arrive with specific DSCP value because collaboration traffic have been remarked at the access layer switch. On the ingress, it's important to remark any traffic at the WAN edge that could not be remarked at the access layer. As a failsafe, in case any traffic from the access switches was trusted through the LAN or wireless LAN. So as I mentioned earlier, this lab does not have access layer switches. So as such, the focus of the identification and classification will be performed on ingress into the WAN edge router. Here we have ACLs that match media and all signaling for both endpoints and servers. I will use the US cube configured earlier to represent the WAN edge router. Everything has been pre-configured, don't worry. So we're just logging to the US cube and we'll prefer a show run in case I wanted to check the configuration with a cube. The next field where we'll review the configuration of the ACL to match the UDP ports, ranges, and DSCP. So first, the QS ARP access list will match DSCP, mark the traffic of EF, AF, and AF42, 41, and application servers such as Expressway, CUCM, Unity, Telepresence Server, Contactor. So these will be configured ACL to matches the application server we mentioned. So show IP access list we have is, for example, we have a QS EF matching my servers, QS application server. Yeah, the AF 41, 42 EF will be marked for all these AF servers. The next ACL is talking about the QS voice. Is the zip profile I showed you. The port ranges will mark them for EF. The other one is prioritize the video. We match it for telepresence, QS Java. For Java video, QS for signaling 50, 60, 50, 61 I talk about. So for the following we'll show you is the policy, the next we'll be showing you is the classes that match the ACL above. So these, so show class map. Showing class map will have a class Java video, video and voice, prioritize video, and signaling. These class map are going to match the access list we have here. The next we'll configure is to show policy map, which matches the classes configured in the above the class map, and set a DSCP. We're showing you or set a DSCP for voice, video, SIP signal on the ingress. We'll notice that the class default sets everything that does not match these DSCP, these classes. And show IP interface brief will apply this policy map to the ingress. So show run into GP1. You take a look here. Is my policy map and set as internal, and is ingress input for ingress marking also. As we mark off the ingress traffic for the voice, video, Java, etc. And next we want to cover the interface queuing. So the queuing will show you how to mark the voice PQ, video CBWQ, and WRED thresh for the CBWFQ. So take a look at this. We'll have all traffic or all endpoints marked as EF, that's map to PQ. And the voice class and the Java shares the same CBWFQ. That's a class-based weight queue. Then the AF41 will mark as a video for endpoints. EF as a Java client. AF42 is video for the Java clients, and we have to reserve the maximum threshold for AF42, approximately 10% to 30% of the queue limit, and the maximum threshold 41, that's 45% to 100% of the queue. What is a WIED threshold? So WIED thresholds is a minimum and a maximum value like configures in the video CBWFQ. So this has show how to WIQ threshold are configured. We'll assume the interface have to be configured with a queue depth of 256 packets. Then the guideline is here, WIED minimum and maximum threshold for the AF42 and AF41. Showing you this show run class map. Well, I show you this class map. Then I will show you configure for WIED in the class-based weighted fair queue CBWQ and DS3 link. Here's the DS3 link, which is 44 BPS. For example, for other high-speed links, we'll go to the bandwidth allocation guideline. So first, what show is the show run policy map. Show run policy map will have talk about ingress marking. Marking we'll talk about here is the queuing for egress. As you see here, we set a voice class. Let's take a look at my class map for voice. This all will be my PQ. So for video, we have marked this. For video, AF41, AF42, we give it a CBWQ. And in between, we give it some WIED, right? Random detect and drop. And last, we give it to the fair queue for the default. And for the signaling, we give it 2% of the entire queue limit. Where to apply this interface? Well, show run interface G2. This is the egress port to facing WAN external interface. We applied egress queuing policy map in the output. Well, so this concludes all about the QoS sets up in Cisco Cube. For the next I will talk about is the admissing control is not used in this case to manage the video bandwidth, but instead to manage the audio traffic to ensure that the priority queue PQ is not oversubscribed. So in this specific example, the voice pool in enhanced location CAC admits the audio for both voice only calls and video calls. In COCM, the feature is enabled by setting the service parameters, deduct audio bandwidth from the audio pool for video call to true under the call administration section in call manager service. I'll show you. Log in. Let's navigate to system service parameter. Again, we'll choose the active one, call manager 1, and the call manager service. What we're going to find out is the deduct the audio bandwidth portion for an audio pool for a video call. We set up the true. So in this case, administration trade a group of video endpoints into a class of maximum video bit rate to limit the bandwidth consumption based on the endpoint type and usage within the solution. There are 3 regions are required in total, and the 3 device pools are required per site. So this applies to configuration where a single audio codec of the G722 use across the entire organization, both the WAN and the LAN. We'll navigate to system. For that, we'll take a look at the region. Click find. Let's click the video 20 MB. Then navigate through the configuration of the region that was configured already for me. So we'll go to the region and we have to take a look. The video is set to 20 MB. Go back. There should be a device pool also configured for each site, as well as one for conferencing and other trunks and apps. In device pool, we can find out this. We have set up just the device pools for the RCD in this demo. So however, the production environment, I will create the 3 device pools for every site. Next, I will review the 5 locations and the link created between them. So there are 2 regional clusters, one in US, the one is in Europe. Each cluster is connected to MPLS the network within the region. The link between SGC and BER sites will be created so the 2 clusters can share information. So with the COM manager, we navigate to system and find location information and location. Let's click find. I will find 7 different locations listed. We'll click the MPLS US. For audio bandwidth, I can see that RCD, RTP, SJC has been set to 1500. If not, I will set up the audio bandwidth, save that. So unlimited has been set up both the video bandwidth and immersive video bandwidth option. So let's take a look at the system device pool. We'll find the RCD phone video 1.5 MB under roaming sensitive settings. Here. We have chosen the RCD. Pick the run RCD 0.5. Okay, we'll pick up the RCD for the location. Then we go next to the link drop down. We have also updated the location settings for the rest of the device pool. Location, RCD. And the last task is configuring LBM, Location Bandwidth Manager, Interclass Replication Group. LBM Interclass Replication Group enables an LBM service to participate either directly or indirectly in an interclass replication of a configured dynamic location bandwidth data. The LBM assigns an LBM hub role participate directly in interclass replication of the location bandwidth data. Let's take a look. It is navigate to the location. LBM hubs discover each other through their common connections and form a fully meshed replication network. LBMs assigned a outspoken roles participate indirectly in interclass replication through the LBM hubs in their cluster. So it's very small in this environment. Only consists of the 2 servers. Most likely in your cluster, configuration will be much larger. So the guideline is under interclass configuration in the preferred architecture when setting up your production network. So the lab will give you the steps necessary to start the replication between the two clusters in the lab. So also configuration make sure the class ID is unique to all clusters. So we'll click the LBM replication group under Bootstrap servers. In the server 1 box, we'll notice a EMEAR call manager. The server has been entered. So this we have configured designated the EMEA publisher as a Bootstrap server. So further redundancy, I can define up to 3 hub servers as a Bootstrap servers. I can verify the information passing between the US and EMEA clusters by going through the serviceability page. So let's go to navigation and serviceability. We'll take a look at tools and the location and the topology. Find. In the results, we will see the locations configured on the US cluster, as well as locations were pre-configured on the Europe cluster. I can expand the BR and FSO, MPLS, EMS, these Europe sites.